Hello everyone, welcome to our presentation which is titled as Causal Analysis of Gastrointestinal Cancer. My name is Arif Chitur Mohammed and here I am with my co-authors Channa Dasaraju and Jonathan Sanchez. Here we discuss the background of gastrointestinal cancer. So coming to the type of cancer, this one belongs to digestive system which will includes esophagus, stomach, pancreas, liver and colon etc. And epidemiology of this gastrointestinal cancer, which is approximately 25% of all cancers cases and deaths in worldwide. Going to etiology, this will depending on the type of cancer and the geographic region, but certain risk factors such as age and gender, family history, smoking, alcohol consumption, and poor diet are known to increase of this risk. Um, Going to symptoms, the symptoms of the gastrointestinal cancer will be abdominal pain, bloating, nausea, vomiting, changes in bowel habits. Coming to the treatment for this one is we'll have three options: either uh, surgery, chemotherapy, radiation therapy, or else immunotherapy, either combination also. Here we discuss the background of gastrointestinal cancer. So the source of our data for our research is from All of Us Research Workbench. So this will be sponsored by National Institute of Health, where we can find the million sets of data, which will be the biological samples and the health information of the people who are staying in the United States. Also, this program will help in like a lifestyle, environment, and genetics to contribute health and disease for the future references. And this data will be very this data will be highly protected. Moving to the statistics of all of this data, the enrolled participants around like 6 million people, and the electronic health records will be like 3 million data sets, and the biological biosample received up to now like 4.5 million. So the source of Here's some core values for all of us research. The first one is diversity and inclusion, which is mainly aiming to include and engage the individuals from the diverse backgrounds, maybe including like vulnerable communities, to ensure that the data should be reflect with full spectrum of population diversity. This commitment helping to address the health disparities and promote the equity in the healthcare. The second one is participant empowerment, where the participation of individuals and recognizing that they are the driving force behind this program. And moreover, their health data make informed decisions about their involvement and have control over how their data is used uh, received from them. Moving to privacy and security, the all of us data will be have utmost care and security for this data, because the program follows rigorous protocols and safeguards to protect participant confidentiality and ensures that data is handled with utmost care and compliance with relevant laws and regulations, so nobody can mislead this one. And the last one, transparency and trust. All of us strives to build and maintain trust with participants and researchers and the broader public. Open communication, transparency in research findings, and regular updates about the program's progress are important aspects of fostering trust and ensuring the integrity of this research. Let's discuss about our cohort selection criteria. The first one, gender. Our cohort haven't focused on particular gender, so both men and women are included in our study. The second one, age. In this part, the age between 18 to 44 persons have included in our age cohort because it's completely relevant to our research question. Moving to the condition codes, the cohort included individuals with any of the following procedure codes, which are all related to the gastrointestinal cancer screening or colorectal cancer screening. The gastrointestinal screening will be like colonoscopy, which will be done on any individual um, not meeting criteria for high risk, and the colorectal cancer screening, fecal occult blood test determinations, and colorectal cancer screening, which will be the flexible sigmoidoscopy. The other one will be ethnicity. We excluded those who choose to skip the question or prefer to not to answer their ethnicity. So finally, our total cohort count resulted with 147,971 count. After setting up the cohort with certain criteria, our first step was querying the data from the database. So our dataset included both demographic information and clinical data. Um, we did analysis by joining both of this data. So the demographic information which are included like age, gender, and the clinical data included with the screening procedures and type of cancers. So the query process involved by extracting the relevant data fields from the database for selected cohort. So this step is very necessary to prepare the data for subsequent analysis. After finishing the step one, we entered into step two, which is creating workspace bucket. So after querying the data from the database, we took the next step to create this workspace bucket to save the data file, which is the required data file. So this is the time saving process, which could be like assessed each time the system was run without any repeated process. So uh, this uh, this is resulted as to easy access to the data in the repeated process. And the workspace bucket also enabled collaboration, sharing this data with our team members. So this step was necessary to facilitate efficient data management and analysis. After finishing the step two, we entered into the most important step, which is the filtering the data. So after filtering the data with top 20 most symptoms, we got 27,035 observations and 29 columns. This is the data we obtained. So in this process, we got the symptoms, which is allowed us to focus on our analysis on the most important features related to gastrointestinal cancer. With the resulted data, which is the filtered one, included demographic information, clinical data, which is related to selected colorectal cancer screening procedures, and topmost 20 symptoms of this interest. So the data set was completely clean and pre-processed to ensure accuracy and consistency of data. This slide describing the binarizing of this data. After filtering the top 20 symptoms, which is completely related to gastrointestinal cancer, our next step was to binarizing the data. In this binarizing step, where we converted the symptom variables from categorical to binary variables, so each symptom was represented by a binary variable with its value of 0 or 1, indicating the absence or presence of the symptoms respectively. After binarizing the data, our next step was to perform temporal analysis. The main aim of this analysis is to identify the temporal sequence of conditions which is related to gastrointestinal cancer for each individual in this dataset. We used the Python program to create a dictionary called temporal sequence to store the temporal sequence of conditions for each person in our datasets. So the dictionary contains person's ID as keys and list of tuples like start condition time, source concept code as values. So we sorted the sequences by start condition time for each person ID to ensure the conditions were in the chronological order. So this step is completely necessary to identify patterns and relationships between the different conditions and to prepare the data for subsequent analysis. This slide is representing the output of temporal analysis. So here we pasted the screenshot of the temporal analysis output after performing that code which is pasted in the previous slide. So based on that, we got this output which is along with the person IDs, along with the dates and the medical codes associated with the diagnosis. Basically, this temporal analysis provides insight into how these medical conditions have changed over time for each individual. So overall, this temporal analysis provides valuable information about the medical histories of these individuals. After performing the temporal analysis, we did pairwise calculations into two parts. So here we discussed about part 1 of pairwise calculations, where we initialize an empty dictionary called pairwise counts, which will store the counts of condition pairs. We iterate through the temporal sequences dictionary using the items method. Within the iteration, we use nested loops to iterate over the indices. For each pair of conditions, we create a tuple pair that represents the condition pair at indices, whether it will be I and J within the sequence. Then we check if the pair is already present in the pairwise counts dictionary. If it exists, we increment the count by 1. Otherwise, we initialize the counts to 1. After iterating through all these sequences, we sort the pairwise counts dictionary by the count values in descending order using the sorter function and the lambda function as a sorting key. Finally, we print the findings by iterating through the sorted pairwise counts dictionary. Each iteration displays the pair of conditions and the number of times they occurred. So the left side we presented our code, and the bottom of the code we presented our output of this code. After part 1 pairwise calculations, we perform the part 2 pairwise calculations. So here the left side we pasted the code, and the bottom of the code we pasted the result. Let me explain the code. So here the sequence of conditions where uh, initializing the empty list to store the sequence of conditions. It's mainly focused on sequence of the conditions. And the second one While sorting the pairwise counts, we enter into the loop which continues until the sorted pairwise counts list is empty. So the third one is pair underscore. So here underscore is used to discard the second item in the tuple, the count, since it's not needed. It is not at all needed. So if pair 0 not in the sequence in the condition, if after performing the pairwise calculations, we perform the lasso regression, which is main analysis for our cohort. So let me explain the code here. The first part, we imported the needed libraries from the sklearn linear model and the sklearn model selection. So after that, we define the dataset, which is input variable and output variable, which is like we mentioned as x and target variable y. After that, we splitted the data where like testing and training dataset. So the x and y data are split into x train and x test, y train and y test, with the test size of 0.2, which is the 20% of the data, and a random state of 42 for reproducibility. After that, we fit the lasso model with the alpha of 0.0005. Later, we included the code to get the coefficients. After that, we printed the coefficients for this lasso regression. The result of lasso regression, we got this output, which we can see the coefficients of different medical conditions in this regression model. The negative coefficients indicate that the corresponding conditions have a negative impact on dependent variable. So the top 5 medical conditions with the highest negative impact on the dependent variable are chronic pain syndrome, vomitings, atrophic gastritis, drug abuse, and simple obesity. On the other hand, the medical conditions with coefficients closer to 0 have a weaker impact on the dependent variable. For instance, anal polyp has the In this slide, we constructed the Netica table with the preceding variables of gastrointestinal cancers with the resulted output of lasso regressions, which is coefficients.